Welcome, thanks for joining me. I'm Mr. B. This is another tutorial that I've created in association with a watt meter. It's to learn how to use the functions of a watt meter in recording some data of electrical devices, and I've used it with a watt lab that I wrote for a class. If you have that watt lab, follow this here video tutorial. It'll help explain details of how to go about the lab. If you want the lab, if you want a copy of it, go ahead and look for my email in my profile. Send me a quick email. I can send you a copy of that lab that will help you out in your class or in your endeavors. So if you like my content, please like and subscribe, share it out to people. I appreciate it. Let's get into it. So on my lab, you're going to follow the procedures. You can see here's a quick screenshot of it. Essentially, then you're going to be filling out a table. I have included samples of tests that I've done, including a griddle grill, a fluorescent light bulb, and then I put the data down for a hot glue gun in low mode and high mode. I didn't complete the data there. That would be for potentially a student or someone who wants to do the calculations themselves, or if they can't show up the day of the lab, they have some information, some details to then use in case they're not available to get to use the actual watt meter. But for those of you that can use a watt meter, let's look at how to use it. Before you get the watt meter plugged in and stuff, you want to determine what electrical device you're going to use. Like I said, I had tested a griddle, electric griddle. I used a hot glue gun, a light. You could also use a hair dryer. You could use a computer or phone, anything with a charger plug, any other device that works off a 120 volt. So that's the standard voltage in most electronics. So this would not work for a stove or a dryer or other devices that are large voltage like 220. These are for the standard devices that you may have. So when you're doing this, you want to always record what your device is. You can often find information stamped on the back, like the griddle grill, or on the light bulb. It was actually printed on the light bulb. But along with that, check for the watt rating. On the griddle, it was rated at 1150 watts. On the light bulb, it was 22 watts. It's very interesting to see when you plug it into the meter, you most likely will never reach those rated numbers. Those rated numbers are the highest rating the devices can handle before components start getting burnt out or fried. So they're typically not going to run at those ratings, and this is good to then see that you, when you do calculations on cost of your electrical devices, you don't want to use these ratings because they're too high. They're higher than what they're actually using during normal usage, okay? To start with your watt meter, you want to push the reset button. It's a tiny little button. You can see in the picture here on the left. I had to use a pen or something sharp to get in there and push it. You're going to reset it. To clear out the memory, it'll probably flash and then turn to all zeros for all the functions. Do this, and then you can have all the function cleared out when you're using it for just one electrical device that you're trying to test out. Before you plug in your device, I want you to understand the modes or functions of your watt meter. Most of them all are very similar. They typically have 7 functions. For this lab, we're mostly going to look at the functions 1 and 2. One is the instant watt usage. That's the watts it's using currently as you plug it in. You'll see this possibly fluctuate up or down slightly. Most things like a light bulb will use a continual wattage throughout the usage. So let's say that it fluctuates just tiny at the beginning and then sits at 18.4. It might be 18.4 as long as the light bulb's on, whether you have it on 10 minutes, an hour, 10 hours, that's what it'll be at. If you use like a griddle or hot glue gun, you're going to see it rise and then start dropping, because when it reaches the temperature it's supposed to reach, then it doesn't need all that electricity. It may shut off the heating element, or it'll drop the heating element's need, and you'll see it lower in wattage. So those are things to watch for. In the number 2 function, cumulative kWh, this will give you the total kWh used during the time it's plugged in. So if you have it plugged in for 6 minutes, that'll be the amount it's used in 6 minutes. And if you want to then use that number to figure out what would it possibly use an hour, you multiply that number by 10, and now that's per hour. Okay, so it's dependent on how long it's plugged in. There is a cumulative timer. We'll talk more about that in a little bit, but I want to go through these functions. The first function, it's shown here just watt. That's the current wattage used. The cost is only if you put in a number of the your local area's cost for electricity. That's in the number 7 here. It's a function you could store information into. So cost is only going to register if you have a number in your function 7 put in. Your number 2 here, like I was saying, function 2, cumulative electric quantity. Okay, that's how much it's used during the time it's been plugged in. And then it's got cumulative time a day. It can keep track of all that stuff. So then we got function 3 is probably over here. The voltage, it'll tell you the voltage. So even if your voltage is 120 to your house, that's what a standard number. It may not be 120. It could be 119, 121, 125, 115. There's variables, and it kind of works on where your home or location is and what city and all these other factors. But it can tell you your instant voltage at your location. You can get your instant current, your amperage, that the device is using, and this would be dependent on how many watts it's using at the time, along with the voltage number. So current is neat to see. Then you have watts in the minimum amount. This will be, like I said, your wattage can go up and down. So as it's recording this stuff, it may give you its lowest number that it receives. Let's say it's 5 watts. And at one point, if it's heating up, it might be 80 watts. So in the max power here in number 6, you'll see the max watts show up here during the whole run. So it'll leave a value of your lowest and your highest in these two. And then, like I said, number 7, function 7 is you can input price and some other information. You would look into your instruction manual to figure out how to do that if you wanted to. Let's go ahead here. All right, take note that the cumulative timer throughout all these, I've seen it stop sometimes. It will stop timing. However, you'll still have it continue to add up the cumulative electrical use. And this is because it stops timing if it sees like roughly less than 1 watt being used. It'll stop timing. So like I was saying before, the electrical griddle, you may have high usage of wattage, and then it drops off when it reaches to the temperature. So then the timer stops, but it's not really accumulating the amount of wattage that is being used in your function 2. Or like in the hot glue gun, I had it go high, and then it was lower, lower, lower. Essentially, the instant wattage kept on lowering, but it was continued to account for and accumulate the total electrical amount used during it. But just be aware, your timer may stop on this device, so I would recommend having an additional timer nearby or watch a clock in case your timer does stop during your experiment. So you're going to plug your device in and start recording data. So you plug it in, start recording data. You want to wait a few seconds kind of to see an accurate reading. As you can see here, I had it at 1 second. It was 2.6 watts. I think that was my light bulb. And then at around 15, it was jumping around 17.6 to like 18.4. So then it starts tapering off for the light bulb, and then it would stay steady the whole time it's plugged in. But as you plug it in, you'll notice it, depending on the device's needs, it will go up or down right away for a little bit there. When in function 2, if you're measuring a device that fluctuates, the amount of wattage used can change, okay? So examples of the heating devices, electronics with movement, like I plugged one of these, a 3D printer, one of my 3D printers into one of these and left that on for 10 hours because the 3D printer is heating things up. It's moving mechanical parts on motors back and forth, up and down. It's doing a lot of different stuff. So its wattage usage, you can't really base it off of just 6 minutes of usage, or maybe even an hour. You'd want to have it running the whole time your print is going. Or maybe if you're plugging a TV in, it may depend on how loud your speakers are or other factors. So in some cases, the function 2 is good to have, because then you can go to number 2, function 2, and you can see the total kWh used by the device during the time you had it plugged in. So like I said, a griddle, hot glue gun, these cases, that's where the function 2 is handy to use. And that is because of this here example, and I'll get a little more into this later. But you can see here with my griddle, it's trying to reach temperature of around, it was like 182 degrees Celsius I measured. But so the wattage jumps up really high, and it's going along at just under, I think it was 1800 watts or so. I can't see the number there very good. Okay, so then when it hits its temperature, it drops down. It shuts off the heating element until the temperature dropped a little bit, then it turned it back on. And then it got to its temperature again, and it dropped the heating element, completely shut the electrical need off. It was registering only 0.2 watts on this low part here. Otherwise, it was up around 1800 watts, okay? So it does that as it's running. So that's something neat to see. It's not a consistent wattage usage the whole time. It goes up and down. And in some cases, imagine the griddle. If you're flipping the lid open and air gets in there to cool it off, and then you put some food on there and you're trying to cook it, well, it's going to obviously then need more electricity to maintain that heat. So our table here and our graph would be quite different because of how we use it. I just left the door closed, the lid closed, and this is how it looked after, I think my recordings here were over 10 minutes long. Hot glue gun, it's something somewhat similar, although it didn't completely shut off, but it was lowering, and you would see that in my table of data. So you're going to be recording your data in a table. Here's an example of mine. The George Foreman, as you can see, if it could read that, so it looks like 1040 watts was the initial start. Then it reached operating temp, so it dropped 0.2. And then it needed more heat again, so it went back up to 1024, it looks like. So that's what I recorded there for a 6-minute period, and the cumulative was 0.061 during that time. Now I did this experiment also cooking some real food for 18 minutes, and that was like a real experiment. Nice to see. That data is not on here, but that was a real experiment. The light bulb, so like here, the rating of the light bulb was 22 watts. However, it ran at 18.6 watts the entire time it was on. So 6 minutes, you can see here that then I took a meter reading on my function 2. I also calculated a separate reading, on which I can talk about that a little bit later here. The hot glue gun, I did it in low mode and high mode. You can see the changing of the wattage. It starts high, it drops a little bit. So 15.6 down to 14, down to 11. In the high mode, it was up to 61 watts, then it drops to 35, 22 watts. As it's starting to reach its temperature, it doesn't need all that electricity to heat up anymore. But if I started pulling the trigger on the gun and getting more glue out, it probably would heat up again, right? Think about how much electricity it needs to melt the glue and all that. So this is columns here then where if you couldn't make it to the lab, you could use this data to still do the lab itself and to help you learn about how this stuff works. So you're going to be recording your kWh at a 6-minute mark. I just made it 6 minutes just so it fit into a class if you're doing this. And you could try a couple different experiments, whether you're doing stuff on a low setting or a high setting. You could do a couple different 6-minute experiments. It doesn't mean you have to do them in 6 minutes. That would be up to you. You could do 12 minutes. You could do an hour if you had the time. You know, that would be up to you. Because so in the function 2 mode, you could then just take a whole hour reading and get your kWh after a whole hour if it was plugged in. But like in a 6-minute experiment, what I have here is 0.001 kWh for 6 minutes. So in that sense, you multiply by that by 10 to get what it would be the full hour, and you'd have 0.010 kWh, okay? So if you are testing a very low watt consuming device, you may also choose to use your function 1 instant wattage to find a more accurate kWh. Example here, that light bulb, well, it used 18.6 watts, therefore it would be actually using 0.0186 kWh over a full hour. You can see how my estimate here off my instant function off the function 2 0.001 reading for 6 minutes was 0.010 for an hour, but in actuality it would be 0.0186 kWh for a full hour if you were truly getting real numbers. And the issue there is that it's just not as sensitive enough to read out more information. If we could see more information, we'd see those other numbers, the 86 tacked on. When I did my griddle, here's a larger picture of my graph now. You can see, to start, when I plug it in, it's trying to get up to a temperature. So the wattage goes up really high, drops a little bit, but then it's trying to heat up until it reaches that temperature setting, and there's a thermistor inside. A thermistor inside of this that tells it, okay, we don't need any more electricity. So it shuts it off down to, I believe it was 0.2, because the thermistor is still running, some circuitry's running, but it's not heating anymore. Until it suddenly has a little bit of a temperature drop, and then it turned back on. Turned on enough to get that temperature just back up again. I think if I recall, my thermometer that I had stuck into there it dropped a couple degrees, maybe 1 or 2 degrees, enough that I could just see it, and then I heard it also click on. These lights went from green when it's cooking or heating, and then it's off, and then back green. It's kind of neat to see that. You could hear it click when it turned on and turned off the heat, or electricity, I mean. And so that's what happens here with this. So if we were just taking instant wattage and we use that value, that wouldn't be accurate for how much electricity this device uses, because you can see that once it reaches a temperature, it shuts off. And then when it needs more temperature, it turns back on. And once again, real usage, if you were flipping this lid open and closed and putting cold meat on there, it would need more electricity, right? We might see this thing fluctuate a couple more times in this here span of timeline here. So it would vary on how it's used. And if you wanted the most accurate result, I would say plug your watt meter into this device, cook on it for the amount of time, measure how much time it is, look at your function 2 kWh, and now you can see how much electricity the device actually really needed in a real circumstance. You're recording data in your table, columns A through G. Once you have that, you will then do calculations to fill in the rest. This is one of my tables before I started adding those other lines that you saw on a previous slide. But you're going to be trying to find electrical cost of the usage and CO2 emissions due to the usage. Basically, you need to find your kWh that was used by your device using this watt meter. So here's a slide that shows you calculation of kWh per day or per year. And it's my example of the griddle and then the light bulb. And I go through the process of calculating out and using values to get my kWh. Okay? I'm getting kWh. That way I can now find the cost, and I use 11.4 cents per kWh in my town. That's what I use for mine, because rates may vary by city. So just do a search online to see what your electrical rate is for your city. And you can take your kWh that you measured, multiply it by your cost, and there you go. That's the cost of running that electronic for whatever time that you measured for. At the same time, you can then determine how much CO2 it's put into the atmosphere with electricity that was needed for your device. And that is this here calculation. So that's how to use a watt meter. for the Watt Lab, or if you came here just to learn how to use a watt meter. I hope this helped you out a lot, and if you're doing the lab, I hope you have fun. Have fun with it. Don't get burnt by any of the hot items like the griddles or the hot glue gun if you try those out. Be careful and cautious, and see what you come up with. Your cost electronics, your CO2 emissions. It's really neat to see all this stuff, and these watt meters are just a great little handy tool to use. If you like my content, please like and subscribe. Come back for more. Thanks for joining me.